Good morning. My name is Richard Moran, Rick. I'm the Chief Architect for Enterprise Cloud Computing, ECC, at Fidelity Investments. We only have a half hour, so I'm going to get going pretty quickly. There's a lot of material I want to get through. Following this, I'll be outside for a few minutes to answer questions we like, because they want us to move on and allow room for the next presenters to come in. But I will hang around for that afterwards if anyone has questions. Okay, so first, quick disclaimer. My lawyers looked over this morning. This is simply just to say that we're not endorsing any specific products or services or vendors or anything like that. Just talking about our experience. Just a little bit about Fidelity. So Fidelity Investments has been around for quite some time. Over $6.8 billion in assets under management. We have about 10,000 technologists in the company, which is about 25% of our entire workforce. So we are a very large technology shop, somewhere in the vicinity of a $3 billion technology shop for a financial services company. We push on creating a culture of allowing risk-taking, creating new ideas, focusing relentlessly on the customer experience, and getting all of our stuff to cloud, as we think there's going to be a lot of innovation and opportunity there. So Enterprise Cloud Computing, the group that I work for, is a centralized cloud organization in Fidelity Investments, and our mission is really to power the next generation of Fidelity digital services for our 27 million plus customers. So build all things. This is a great theme for this conference. I'm an engineer at heart. I love to write software and build stuff, but there's more to it than that. We also have to ship all things, and we have to run all things, and we want to do it in the cloud. But there's a lot of challenges to making that happen, and I'm going to try to talk through some of those challenges that we've encountered along the way, and some of the ways that we've tried to solve some of the problems that we've hit. We haven't solved everything. We've got a long way to go. It's an ongoing journey. But I think we've learned a few valuable things that would be good to share. So, some epic challenges. Everyone heard of the Ice Bucket Challenge? You've seen this one on the internet? The Cinnamon Challenge. Hopefully no one's tried that one. That one looked really scary to me. We're going to talk about the Cloud Challenge. If there's time at the end, we'll talk about the other two a little. So looking at the landscape, cloud is big, and there's lots of clouds out there. Lots of public cloud providers. There's private tenant, public, your on-prem stuff, hybrid models where you're doing some of each. There's opportunities for innovation, machine learning, artificial intelligence, data analytics, a lot of stuff at scale, things that you really can't do on-prem. You don't have the services there. But there's also some risks: audit, compliance, security. You got to protect your corporate brand out there and your customers' data. That's especially important for Fidelity. So lots of options and lots of questions around what to do. So what is the cloud? Just a little bit of grounding context really quickly. Well, it's elastic. Dynamically adjustable services. It's scalable. You can scale up or scale out, bigger machines or more machines of the same size to meet the demands that you have. It's pooled, so you're not in there by yourself. Unless you pay extra and with the cloud service providers, you're not going to get your own private machines. You're going to be on machines with everybody else. Multi-tenant pooled resource environment. And it's dynamic. We've heard talk about the age of the developer. This is what's powering the age of the developer. Developers can go directly to these APIs in the cloud, provision infrastructure, provision services, and build applications quickly. Why would we go to the cloud? Well, a typical use case scenario is you have your business partner. They have an idea. They want to get that idea out to the customer in the form of a delivered capability. They need a developer for that. So they talk to the developer. The developer is going to build them an application or services. In order to do that, they're going to need infrastructure. So they're going to need to order some things. So they call a vendor, and they get the vendor to deliver it. The vendor will get it to the data center. It'll be delivered to the data center, and for those of you who have dealt with this in the past, it takes a long time to order new servers and machines and wait for them to show up on the loading dock, get into the data center, get racked, stacked, plugged into the power, plugged into the network, set up, configured, and then finally made available to you. It's a long cycle. Finally, that's delivered to the developer. The developer can build the application, put it on the servers, give it to the business gives it to the customer. Well, that's great, everybody's happy. What if the customer really likes it? Well, now you're going to need more instances of that application, more infrastructure. So that's going to cost more. You're going to have to go through that cycle again and get more machines in. What if you have more ideas? You want more applications or expanding the application. Again, you're going to have to have more servers. What if you have a market event? You know, we have a Brexit event, or we have events like we had on February 6th of last year. All of a sudden, we're running at 6x our normal capacity. You know, how do we handle that? Well, unless you've statically provisioned all the machines you're going to need, you're going to be in some trouble. So why do you go to the cloud? Time to market, get that elastic scaling to handle market event and increased customer demand. Utility billing, so you're paying only for what you use. So I don't just statically provision stuff and put it in our data center and have it sit there. I can, on a utility model, consume what I need and then shut down when I don't. Which is really nice, because in the past, in order to handle your worst case scenarios, you have to statically provision infrastructure ahead of time for your worst case scenarios and then have it sit there idle and do nothing most of the time. A typical server capacity for us across the enterprise in general is 5 to 10% utilization. Most of it just kind of sits around and doesn't do much. In the cloud, we can take care of that with elastic scaling. We scale out to use what we need and then scale back down again. So a number of challenges to getting there. So that's kind of the what and the why. The challenges are really around the how. So we'll talk a little bit briefly about each of these. So what's the first move for strategy? Well, when we began our cloud journey years ago, it was each line of business, and even down to individual development teams, kind of doing their own thing, each building their own highway to the cloud, their own automation, their own pipelines, their own ways of doing things. And we had about 20 different ways of doing security, audit, compliance, all of those pieces that go along with it. And that posed a lot of problems: inconsistency in operations, inconsistency in security, and inefficiency, because many different teams were duplicating the exact same tasks. You know, people doing the same thing. So we decided to move to a centralized approach. So we're a federated business model. We have a bunch of different lines of business, each with their own CIOs and their own technology organizations. But we are a centralized group that serves all of them, with the idea that we make getting to the cloud more efficient and consistent. So we want to enable a better developer experience that'll help us move at speed with security, compliance, and reliability. So being able to do all that at scale. That's what our organization is really all about. So a single highway to the cloud, and our lines of business can drive whatever car they want on that highway. We just don't want them building their own highways. So some of the basic principles behind this, that drive how we're putting this together. I'm an architect, so I love principles. I love talking about principles as kind of the grounding for any of our discussions. Leveraging open source. That's always a good start. Buy versus build. Again, I'm an engineer. I love to build stuff. Most engineers, software engineers, love to build stuff. But we need to concentrate on building things that provide differentiated value to our business, and buy the things that don't. Things that are for competitive parity, things that aren't differentiating, you should buy those and configure them or get them from open source. Minimal customizations. So again, even when we buy stuff, we tend to customize the heck out of it. And for Fidelity, we used to call it fidelitizing a product. We're not doing that anymore either, because that causes a lot of problems for support and really makes it difficult to upgrade vendor products and things that you bring in. Self-service. This is absolutely critical for any centralized IT organization that's servicing a larger set of business units. You can't be in the way. We can't be a blocker. So we have to enable self-service capabilities so we are not the middleman. We're not the one sitting there that people are waiting on. Everything is a service. So everything exposed as APIs that are decoupled and can plug into whatever orchestration and automation mechanisms that we want to build. Everything is code. So not just your application code, your configuration, your infrastructure code, CloudFormation templates, Cloud Foundry manifest files, Helm charts, all of those things, everything as code. Full automation, end to end. If you want to go to the cloud, you really need that full end-to-end automation, which includes test automation and everything in between. 12-factor design. We'll talk a little bit more about design a little further on. Pace over protection. Now, this is a hard one, especially in our space where we're dealing with a lot of brokerage and financial applications. They're coming off of mainframes. They want things to be really almost perfect, and they can't be in the cloud. So we have to strike a balance with pace over perfection. Move quickly, get as much done as we can, provide the baseline capabilities, and then keep iterating on it and making it better. We want to go to multi-cloud. We don't want to be stuck in the same one. We need a scalable cost model, which means we really have to pay attention to our consumption and our resource management in the cloud. And then security and audit support. I put that one last, but it really is one of the most important things that we do. So, how do you know if you're ready to go to the cloud? Well, there's a few different buckets for this. So there's teams and parts of organizations that aren't cloud ready. So not a lot of cloud skill set, not a lot of cloud certified folks, probably not a lot of automation, not much in terms of DevOps, minimal agile practice, probably don't know what 12-factor is and haven't really done much with that. No real app observability, so maybe some logging and things like that, but nothing very sophisticated, and minimal security controls. On the other end of the spectrum, you have groups that are really cloud ready. So these guys are advanced, they have strong cloud skill sets, they're all AWS certified, Azure certified, full CI/CD automation, mature DevOps practices and agile practices. They know 12-factor, they build 12-factor applications. They have sophisticated app observability, with logging, monitoring, alerts, very proactive, and then automated security controls and gates. And then you have the middle path, which is on the way from not cloud ready to cloud ready. We have to tailor our services to match up with each of these different kinds of groups at these different levels. And the trickiest part for us is when we deal with folks who are in the middle part who think they're on the end part. And we have to spend a lot of time helping and working with those groups. So security, how are we secure? Again, starting with principles. We encrypt everything at rest and in motion. As I mentioned earlier, fundamentally, no matter what we do in the cloud, our number one mission is to protect our customers' data and protect our brand. We do not want our customer data being compromised. We don't want to end up in the newspaper. We want to protect our customers and ourselves. So we encrypt everything. That's something we do not compromise on. We do enterprise managed encryption keys. So we generate our own keys, our bring your own key model to the public cloud providers. So we manage our own keys so that the public cloud provider can't decrypt our data themselves. They don't have the keys to be able to do it. Federated identity management integration. So whatever SSO and identity management systems you have, whether it's Active Directory or other things, you want to integrate that into your cloud service provider environments. Role-based access control. Again, with a minimal access type of methodology. You want to give the minimal amount of access that you need to be able to get the job done, rather than broad and open controls. Network isolation policies at the software product level. So whether this is an application or a group of applications, you want to get it down as fine-grained as you can. And this is something, at least for us within Fidelity, in our internal network, it's pretty much wide open. We have production and non-production. They can't see each other. But if you're in either of those networks, almost anything can see anything else inside those networks. In the cloud, we have the capability to really control that at a much more fine-grained level. From app environment to app environment, we can control what things can see other things and have very good network policies and controls in place, configuration, as code. Ingress and egress controls. What can come into your cloud environment from the internet? From your cloud environment, what can get out? And how do you control that? So we create egress proxies with policies and web DMZs that handle ingress and egress, and we implement those in the cloud providers. Automated governance gates and controls. Has to be automated. And then monitoring, detection, and auto remediation. It's a shared responsibility model. So there are pieces that our enterprise security team handles. There are pieces that the cloud security team handles. Now, in different companies, these may be in the same organization or they may be different. In Fidelity, they're different organizations that collaborate together. And then there's obviously responsibilities for the cloud provider and for your application teams. But your identity access management, your cybersecurity incident response teams, the CIRT, threat and vulnerability, penetration testing, all of those kinds of things. Doesn't change in the cloud, has to be there. So automating the controls. So when we did our first implementations of security and gates, we had checklists. They were spreadsheets, 30, 40 questions. It was very laborious to go through what we called cloud attestation. But it was a start. We had to start somewhere, and we weren't able to automate it at first. We're now automating all of it. So all of these gates are automated as part of our deployment pipelines, so that if you're following through on our automation and going through our deployment process, all the stuff gets done for you. And it's really very powerful for us to be able to do that. We also do a lot of detective control, so that's the preventative, making sure that bad stuff doesn't get in. Then you have the detective controls, so things that we're monitoring in the cloud environments, and then auto remediation. So do we have unauthorized machine images out there, in AWS, AMIs that shouldn't be there? Do we have S3 buckets with unencrypted data in them? And we need to be able to detect these, respond to them immediately, and shut them down in production. Now, when we began this, first it was notification. We'd send out notifications that we've detected you're running a bad machine image or an outdated machine image. You have unencrypted data in a bucket. We send the notifications, and then there's a time period, and then we'd shut it down. Now we're at the point where we're just shutting them down. So we send out the notifications, and things just get shut down. And then compliance and audit. Especially for us in financial services, there's a lot of burden for compliance and audit. And depending on whether you're going into the native environment or whether you're doing PaaS or Caas, which we can talk about a little bit, there's different work that you have to do to make things SOC 1 compliant or SOC 2 compliant. And having gone through that with platforms like Cloud Foundry, I have some good firsthand knowledge of what that's like. It's not easy. Ultimately, what we want to get to is audit as code. If anyone's been through an audit of their software system, if you're not automated and you don't have the data readily available, it's very painful because you'll have to step through it with the auditors. You have to go find proof of all of the change controls, who changed what, when, and how. But if you automate it and you have all of the events and all of the data captured as part of your pipelines and controls, and you have dashboards and reports, you can just hand it to an auditor and say, have fun. You can take a look at it. So that gets us into operations. So once we get into the cloud, are you ready to operate there? Cloud operations has a lot of aspects to it, but it really comes down to three basic things: tracing, alerting, logging. So the ability for us to diagnose problems, hopefully more and more proactively. So we start with capturing all the data and then eventually can apply things like machine learning to be able to identify patterns and look and see when things start coming out of bounds from your expected patterns. That's really helpful because there's a lot of noise. If you're capturing telemetry, you're capturing logs at the platform level, you're capturing application logs, you're capturing security logs. That's a ton of noise, a ton of data. So you need some things to be able to filter and shift through it and tell you what's really important. Even for things like Cloud Foundry, we get a ton of data out of our Cloud Foundry environments. How do we know what's really important? How do I know when something's really a problem? If I see that Diego cells are up to an 80% memory utilization, is that a problem? It's hard to tell. If it's way out of the norm, it probably is. So knowing those patterns. So health visibility, having the right operational tools, proactive operations, and then the overall process, change management process, incident resolution, and even, when you get more advanced, chaos engineering. Being like Netflix and being able to do chaos monkey in production. We're not there yet, but we'd like to be. And then also under operations is resource management. So I mentioned earlier that one of the benefits of going to the cloud is that you don't have to have statically provisioned infrastructure for your worst case scenario, that you can scale up and down as needed. That's great, but the cloud provider is not going to tell you to do that. They're not going to tell you, gee, you're running machines that are doing nothing most of the time. They're just going to send you the bill and thank you when you pay them. And we're finding that in our initial waves into the cloud, we're now having to optimize. We put a lot of stuff out there, but we're spending a lot of money. So now we have to look at how do we manage the cost for the infrastructure. EC2, Elastic Block Storage, S3, RDS, network, all of the things that infrastructure we're getting charged for. So we need to look at the utilization, which even in the cloud, although it's better than maybe the 10% we're doing on-prem, it's still about 20% or so, and we're trying to get better and better at that. Memory is a good metric for scaling out, horizontally scaling. And we have a lot of oversized machines that are just running all the time. We provision pre-production and test environments, and we just kind of leave them out there running. And that's something that we're correcting right now. And a lot of the migration strategies to the cloud don't help this. When you simply take VM workloads that are on-prem and you lift and shift them to the cloud without changing any of the behaviors and the way that you do things, it's going to be the same in the cloud. And actually, it's probably going to be more expensive than it was on-prem if you run the way that you were on-prem in the cloud. So you need some cost management strategies. So you need visibility. So you need tools. AWS and Azure and other cloud providers have some nice built-in tools that give you visibility to billing. But there's also some good vendor tools out there, and we use some of those. And we provide that visibility directly back to the business units and the application teams that are using those resources so they can see exactly what it is that they're spending. How much of all of these resources are they using, what kind of bills are they racking up. We're looking at opportunities to use reserved and spot instances, moving up to the latest machine types whenever possible. So when the C5 is available, we move up from C4 to C5 on Amazon. Auto-scaling and automated instance shutdown. So we're starting to put tools in place that will look for idle workloads and shut them down. And scheduling things. We know that there are development environments we're not using on the weekends, just shut them all down. And we can spin them back up again Monday. And then, of course, right sizing, making sure that you're not using oversized machines. You're using a machine with way too much memory and way too much CPU for your workload. You're spending too much on it, so you want to right size it down. So those tools can give you that kind of visibility into what that looks like. So do you have a good design? This is one of my favorite architecture fail pictures. You would think if they're designing this bridge and this highway, they would have known a long time ago that they were off. Hopefully on paper they would have known they were off. If you don't design well for the cloud, you're going to end up in a bad place. So you have to think differently. Self-healing systems, smart applications, patterns like circuit breaker, health checks and metrics, frequent rehydration. So we want to get to the point where we're rehydrating all of our servers, all of our containers, every few weeks, every 30 days at max. So, gone will be the days where our operating system hasn't been updated in a year, or we're running Java 4 and we've never updated it. We can't live that way in the cloud. It's dangerous enough to live that way on premise. We absolutely can't do that in the cloud. We have to rehydrate things all the time. DevOps pipelines, you have to have that automation. Everything is a service. Backing services. You don't want to be depending on anything that's specific to the infrastructure and the environment. You don't want to have your application really depending on something that's in the OS. You also don't want to hard code routes. You don't want to have a service that's on a particular endpoint on a server or an IP address. It's got to be dynamically routable in the cloud because things fail in the cloud and they come up in other places. So everything has to be routable dynamically. App teams are responsible for security. They need to build it in from the bottom up. No interactive access to production. So you can't SSH into the production box or your container instances in production to see what's going on. You can do that in development, but once you get to pre-production and production, everything should be automated. And you should be getting, from your observability, you should be getting all the telemetry out that you need to be able to tell what's going on. Know your network up front. So know how you want to design your network, know what your network flow and data patterns are for how you're going to be moving data back and forth, because you get charged for it. The cloud service providers, especially Amazon, ingress is cheap. Putting data in is cheap. Getting data out is expensive, and that's by design. So you really want to think about the way that you're doing that. And then ingress and egress. How do you want to talk to the internet back and forth? Designing for the cloud with 12-factor, making things stateless and fault-tolerant. Deploying smaller apps, so breaking things down, not having monoliths. And making efficient use of the infrastructure, which I talked about previously, monitoring your resource consumption and what you're doing. And then just the overall shift from smart infrastructure to smart applications. So if you're thinking about some of our current systems and even mainframes, those systems are near bulletproof. They're very solid. And the applications can pretty much count on the infrastructure being there. In the cloud, that's not true. Infrastructure and services fail all the time. So your application now has to be smart. It has to be resilient, fault tolerant, have health checks, circuit breakers built in, be able to auto scale, and be able to load balance. And then patterns. So this isn't an endless list of patterns, but we've identified kind of a top 10 set of cloud patterns to help us focus our efforts in terms of automation, security, and deployments. So content management, web applications, web services, batch applications, event-driven applications, data analytics, cloud databases, virtual desktops. So we're building out a lot of automation around these particular patterns. And many application solutions end up being combinations of these patterns, not just one. But this is guiding how we're building out our automation. So once you've built your app and you want to ship it out, what's your target? Where are you going to put it? Well, there's a lot of different runtime options. And starting at the bottom with hardware, which is your actual physical machines, moving up to infrastructure as a service, container as a service, platform as a service, function as a service. The higher up that stack you go, the more time that you're spending on your application and the less time you're spending on infrastructure. Now, there are trade-offs to this. The higher up you go, the more constraints there are, the more opinionated it is. So you have a little less flexibility because you're running within a determined environment. But you get to value for your business faster. So you have to make those decisions and trade-offs as to which one of those is best. So we want to place workloads where they will maximize value to the business as quickly as possible and align to your overall strategy for how you want to deploy your applications. I think I will skip these. This is just showing a comparison of Cloud Foundry, which uses Garden and has application services, with a container as a service environment and how Kubernetes works. One of the differences is that Kubernetes is much closer to the infrastructure. There's more work to do in a Kubernetes environment than in a PaaS environment like PCF. You really have to pay attention to how you're managing a cluster in Kubernetes, whereas in an environment like Cloud Foundry, you do not. Let's see, there we go, platform as a service. The key thing, though, to look at is this. This is really the difference between PaaS and CaaS. So in a platform as a service environment, you never see the container. The container is dynamically built for you on the fly by a build pack, and then it's run in a stem cell, what's called a stem cell in Cloud Foundry terminology. In a Docker Kubernetes environment, you have to build the container, and then you're deploying the container out. And one of the big differences there is when you build the container, you're responsible for the language runtime, Java, Node, .NET, whatever you're putting in there, and the operating system. So as a developer, I have to worry about those things, and I have to manage the life cycle of those things as I package them in my containers. And then just from an effort comparison, I'm focusing on PaaS and Caas here. There's a lot of other options, but PaaS and Caas are where most workloads are going to go. When you're taking stuff up to the cloud, most of the time things are going to end up here. There's a lot of work to do in a Caas environment. So if I'm going to do Caas on AWS, which is EKS essentially, I have to set up an AWS account. I have to do cluster and pod management. There's a lot of runtime work I got to do. I got to deal with my routes, certificate management, the security features that right now are not really there, application lifecycle management, and then the operational stuff with logging and monitoring. In a PaaS environment, most of that is taken care of for me. So it's much easier to do the deployment. And again, the balance is there's more restriction and constraint in a PaaS environment, but you get to where you want to go with the app quicker. So if you can live with those constraints, it's a good trade-off. Whereas in the Caas environment, more flexibility, but you have to do all that other stuff before you can actually get to delivering business value. And then we put this together as guidance. So your application deployment runtimes. So your PaaS, your Caas, and then non-container apps. So you can see that web applications, web services, microservices could go in either space perfectly well. But in general, like I was showing before, you want to try and go as far up that stack as you can. I am told I am out of time, so I'm just gonna jump really quick through to this. An end-to-end automation pipeline that describes kind of pulling all of these things together that I've been talking about all the way through. These are the pipeline outcomes that we want to get to: standardization, security checks, verification with fingerprints, readiness checks. And then in terms of an exit strategy from the cloud, you want to think about portability. Think about the services that you want for integration, because the more you integrate to native services, the more tie-in you've got. Think about having a multi-cloud strategy, fully automate with everything that's code, and think about containers, whether it's Cloud Foundry or Kubernetes, containers. And then finally, make sure when you go into the cloud, have a business strategy, not just a technology strategy. Be careful about going in on one cloud provider. Make the leap from infrastructure reliability to application resiliency. That's critically important. Pay attention to the shared responsibility model with the cloud providers. And watch out for your infrastructure bubble, because for a while you're going to have your on-prem infrastructure that you haven't shut down yet and new infrastructure in the cloud. So you have to worry about how long you're going to maintain both those things before you can shut the other one down. Thank you very much. I'll be outside if anyone needs questions.